The Hubble Space Telescope has been orbiting Earth for more than 34 years, and during this time its mission has proven to be nothing short of extraordinary. Although Hubble was not originally designed to study objects within our own solar system, it has continually expanded our understanding of these bodies and has provided a wealth of images and data from distant galaxies. Through its long tenure in space, Hubble has managed to capture a myriad of remarkable moments and celestial phenomena, offering insights into the universe that otherwise would have gone unnoticed. The ability to observe distant objects beyond our solar system is what Hubble was primarily built for, but its contribution to studying the planets, moons, and other smaller bodies in our solar system has been a significant bonus. In fact, not every planet or celestial object in our solar system has its own dedicated space mission, so Hubble's observations have been pivotal in revealing aspects of our cosmic neighborhood that would otherwise be overlooked. There's much more to explore in our solar system than just the well-known planets, and through Hubble's eyes, we can venture into the farthest reaches, uncovering strange and awe-inspiring objects that most people have never heard of before. Together, let's set off on a journey, starting from Earth and extending outward, as we discover fascinating objects and phenomena that exist beyond our familiar view of the universe, all thanks to Hubble's exceptional vision. Our journey begins close to home, with the Moon, our nearest celestial neighbor. The Moon is quite large in our sky, and because of its size, Hubble cannot capture its entire surface in a single image. Additionally, there are other space missions, such as NASA's Lunar Reconnaissance Orbiter, which provide much clearer and more detailed images of the Moon's surface than Hubble can produce. Given this, Hubble's resources are often better spent observing other objects in space that are less frequently studied. However, in 2012, Hubble captured a remarkable image during a special event. Venus passed directly in front of the Sun, a rare occurrence known as a transit. While it might seem odd to observe the Moon during such an event, scientists used it as a giant mirror to detect subtle variations in sunlight scattering as it passed through Venus's atmosphere. These variations provided important data about Venus's atmosphere, specifically regarding its chemical composition. While scientists already had a general understanding of Venus's atmosphere, this experiment was designed to test whether the light-scattering method used in this approach could provide accurate results for such studies. In fact, Hubble regularly applies this technique to study exoplanet atmospheres by observing distant stars as planets pass in front of them. The Sun itself is too bright for Hubble to observe directly, so by using the Moon as a reflector, scientists were able to gather the information they needed without directly observing the Sun. This clever method allowed Hubble to make a significant contribution to the study of Venus and its atmosphere, even though it was not observing the planet itself. Although Hubble faces challenges when attempting to capture the entire surface of the Moon, it has no such issues when it comes to Mars. Hubble frequently observes Mars, offering a complete view of the planet, something that orbiting spacecraft often struggle to achieve. These detailed observations of Mars provide invaluable data on the planet's surface, weather patterns, and seasonal changes, as well as its dust storms. This information is critical for planning rover operations and constructing a more thorough understanding of Martian weather, which will be essential for future space missions and even potential human exploration of the Red Planet. One of Hubble's time-lapse sequences shows a global dust storm that completely engulfs the planet, obscuring surface features. In the background of the image, we can see Mars's two small moons, Phobos and Deimos, moving rapidly across the sky. Their motion is particularly noticeable in a 42-minute sequence, highlighting how quickly these moons orbit Mars. Another of Hubble's time-lapse sequences focuses on Phobos, the larger and closer of the two moons, showing its movement. Over a mere 22 minutes, Phobos orbits Mars in just 7.5 hours, making it the fastest moon in the solar system, even faster than Mars's own day. As we leave behind the inner planets and begin our journey toward the gas giants, we pass through the asteroid belt, a fascinating region filled with thousands of objects worthy of study. One such object is the intriguing asteroid 6478G, a misnamed celestial body that has captured the attention of astronomers. Despite its appearance, which seems to suggest it is a comet, due to its twin tails, asteroid 6478G is, in fact, an asteroid. It resides in the asteroid belt, and Hubble captured detailed images of it in 2019. So what gives this asteroid its comet-like appearance? Scientists believe the answer lies in a phenomenon known as the Yarkovsky effect. Solar radiation exerts a small but steady force on irregularly shaped objects in space, gradually altering their rotation. In the case of asteroid 6478G, its 3.5 kilometer-wide body has been spinning faster over time, completing one rotation every 2 hours. This rate of rotation is the maximum limit an asteroid can withstand before it begins to break apart. As it spins at such high speeds, centrifugal forces become stronger than the asteroid's gravity, causing loose material to be ejected into space. This ejected material forms the tails seen in Hubble's images. Over time, asteroid 6478G will likely disintegrate completely. Like many other comets and asteroids, 6478G is not made of solid rock, but is instead a fragile rubble pile held together by weak gravitational forces. The asteroid belt is home to a dynamic population of millions of objects, ranging in size, from small dust particles to massive asteroids larger than a kilometer. One such object, P2010A2, presents an intriguing mystery. At first glance, it appears to be a typical comet, but a closer inspection reveals an unusual filamentary structure at its center. Surprisingly, this is not the comet's nucleus. In fact, P2010A2 is not a comet at all. Rather, it is the aftermath of a rare and dramatic event, a collision between two asteroids. Collisions between asteroids are incredibly rare, as these objects typically travel in relatively stable orbits. However, the asteroid belt remains a chaotic region, and occasionally objects collide with one another. These collisions are difficult to observe in real time, which makes each recorded event an invaluable opportunity for scientists to study the physics behind such impacts. The X-shaped structure observed in Hubble's images is the result of an asteroid collision that likely occurred at speeds tens of thousands of kilometers per hour. Such high-velocity impacts release tremendous amounts of energy, shattering solid rock and scattering debris across space. The debris from the impact doesn't disperse evenly but rather follows complex, gravitationally driven patterns. Some material is thrown outward in 4 distinct directions, forming the X-shaped structure seen in the images. This unusual arrangement arises from the way the colliding asteroids fragmented upon impact. Some of the debris is eventually pulled back toward the asteroid's center of mass due to gravitational forces, while other fragments gain enough velocity to escape entirely, forming a faint tail that is similar to the tail of a comet. However, unlike typical comet tails, which are driven by solar radiation and gas sublimation, the tail in this case consists purely of debris from the asteroid collision. While most asteroids in the belt follow relatively stable orbits, some may be sent off course by gravitational forces, particularly from Jupiter. Often referred to as the vacuum cleaner of the solar system, Jupiter is a massive planet that exerts a powerful gravitational pull on nearby objects. With nearly 3/4 of the solar system's mass outside the Sun, Jupiter's influence shapes the fate of objects in its vicinity. One famous example of this occurred in 1994, when the 2-kilometer-wide comet Shoemaker-Levy 9 ventured too close to Jupiter. The planet's immense gravity not only captured the comet, but also tore it apart, breaking it into several fragments. When these fragments eventually collided with Jupiter, they impacted at speeds of 60 kilometers, creating fireballs that reached temperatures of over 23,000 degrees Celsius and soaring thousands of kilometers above the planet's surface. The most significant impact left a dark spot on Jupiter, measuring 12,000 kilometers across, about the size of Earth itself. The energy released during the impacts was equivalent to 6 million megatons of TNT, over 600 times more than the combined nuclear arsenal of all nations on Earth. Though many subsequent impacts on Jupiter have been less dramatic, they have still been observed and documented, lending further credence to the idea that Jupiter plays an important role as a cosmic shield, protecting the inner planets from catastrophic collisions.